Welcome to the YC500 Microinverter and ECU Installation Training. This is the first in a series of online training modules for the APS product line of microinverters and ancillary accessories and supporting software applications. The target audience for this video training session is solar array installation technicians who may or may not have experience in installing solar microinverters and need to familiarize themselves with the potentially unique aspects of the APS YC500 installation. But before we get started on the actual training, let's take a few seconds to talk about getting yourself registered as an installer with APS. If you've not already done so, email APS technical support at support@apsamerica.com, letting them know that you need to get registered. Please provide the following information: company name, company address, including area code, company phone number, contractor's license number, contact name, contact phone number, contact email address, and the name of your distributor. You will not be able to set up your customers with online monitoring without being a registered APS installer, so it's critical that you get this done in advance of actually installing an APS system. Technical support will send an email to the contact name provided when the registration process is complete and your installer account has been set up. Now, on to the training. There are three basic components that make up the APS system: the inverter, in this case the YC500, the Energy Communication Unit, or ECU, and the Energy Monitoring and Analysis Website, or EMA. The inverter's role in the overall solar system is to convert the DC power that is generated by the solar panels into AC power, which can be utilized by the power grid. The YC500 is a grid-tied microinverter. The APS YC500 functions as two inverters built into a single case and has the following characteristics. It's a single-phase inverter, but given its architectural flexibility, it can also be used in both 208 volt and 277/480 three-phase applications. It is best suited for PV modules in the 180 to 310 watt range, and its total rated output power is 500 watts. The maximum number of units per 120/240 volt 20 amp on a circuit is 7, or a total of 14 PV modules, and the maximum number of units per a 208 volt 20 amp circuit is 6, or a total of 12 PV modules. The YC500 uses the Power Line Communication, or PLC protocol, to communicate with the Energy Communication Unit, the ECU, and while the warranty varies depending on pricing, it has been engineered for a design life of 25 years. The ECU collects and stores the performance data from each of the microinverters and sends it to the APS database so that the array can be monitored via the internet. The ECU, while optional, is an essential component of the remote monitoring system that should be thought of as the gateway to the performance information that can be retrieved from each inverter and its assigned PV modules. Again, the ECU uses the PLC protocol to communicate with each of the inverters. Please note that the ECU is not a wireless device and requires an electronic bridge or direct Cat5 connection to communicate to a network router. The Energy Monitoring and Analysis, or EMA website, allows for 24/7 management and monitoring of the solar array via any web-enabled device, such as an internet-connected computer, tablet, or smartphone. While the EMA functionality is covered in depth in another training session, a few basics are in order so that you have a better understanding of how the entire system is designed. First and foremost, as we've already stated, and you'll hear as a recurring theme throughout all of our training, the EMA is accessible to you and your customers only after you've registered and have an APS EMA installer account. Next, you and your customers have different levels of visibility into the system's data and management functionality. While your customers can view overall system performance, you'll have the ability to query their systems at a much deeper level, as well as manage performance parameters depending on specific system requirements. This is a simplified typical residential single-phase system diagram. Things to note here are that, as described previously, the YC500 is assigned to two PV modules, typically described as Side A and Side B. When hooking up the AC cabling, there are three conductors: the red L1, the black L2, and then the neutral, which is used in the PLC communication with the ECU. A quick word on ECU placement. The ECU is plugged into a standard 120 volt outlet, and you want to get it installed as close electrically as possible to the array to eliminate as many communication problems as possible. Here is a picture of the YC500 showing its associated cabling. It's important to note that the YC500 does not use a trunk cable for AC distribution, but rather are daisy-chained together in series. The top cables in the photo are the AC cables, and the bottom four, two on each side of the inverter, are the DC input cables. Again, as review, the maximum number of units per 120, 240 volt, 20 amp on a circuit is 7, or a total of 14 PV modules, and the maximum number of units per a 208 volt, 20 amp circuit is 6, or a total of 12 PV modules. Additional components that are important to a successful installation are the AC branch cable ends, or whips, and the end caps. The AC branch cable ends have a connector at one end for attaching to the first YC500 in a circuit, and bare wires, red L1, black L2, and white, neutral, at the other end for connecting into a junction box. The end caps, as their name implies, are weatherproof termination caps that lock on to the last YC500 female AC connector in the circuit as protection against the elements. The YC500 is compatible with both 60 and 72 cell PV modules with a voltage range of 22 volts to a maximum of 55 volts. It requires the 22 volts to energize. Anything below that voltage level on the input side of things, and the inverter will not power up. Okay, with all the background information out of the way, it's time to start walking through the actual installation procedures. Step 1. With the racking system installed, lay out and mark on the racking where the YC500s are going to be installed, keeping in mind where the PV module junction boxes are going to be located and avoiding any other possible obstructions. Then go back and install the inverters using your marking as a guide. Do not mount the inverter where it'll be exposed to direct sunlight. Under the PV panels is preferred, where the panels are providing shade for the inverters. While the YC500 is designed to tolerate extreme heating conditions up to 185 degrees Fahrenheit, we've found that operating in direct sunlight will quickly push those limits. Just as a note, as a safety measure and out of self-preservation, the YC500 will shut itself down when it reaches the upper limit of its operating temperature range. And it is extremely important to allow at least 3/4 of an inch between the roof or mounting surface and the bottom of the inverter. This spacing is important for cooling airflow to reach all surfaces of the inverter. Step 2 is making sure that the inverters are properly grounded throughout the system. A note about grounding. The YC500 is not internally grounded within the chassis, so it requires an external ground. Depending on your jurisdiction, and it's always best to check with your local inspector to get their ruling on the subject, you can either use a grounding washer when attaching the inverter to the rail of a well-grounded racking system, or you can use the grounding lug on the YC500 to string bare copper wire to an appropriate system grounding location. Step 3 involves installing the AC branch circuit junction box in a suitable location, as close to the end of a branch of modules as possible. You'll have approximately 12 feet of AC cable to work with, 6 feet of cable associated with the last inverter in the branch, and 6 feet of AC connector cable, sometimes called a whip. Make sure to wire the conductors. L1 is red, L2 is black, and neutral is white. With the inverters mounted on the racking system, the grounding all sorted out, and junction boxes installed in the appropriate locations, it's time to connect the microinverters together on the AC side. First of all, plug the AC female connector of the first inverter to the male connector of the next inverter, and so on, to form a continuous AC branch circuit. When doing so, remember the branch inverter limits. The maximum number of units per 120 240 volt 20 amp on a circuit is 7, or a total of 14 PV modules, and the maximum number of units per a 208 volt 20 amp circuit is 6, or a total of 12 PV modules. Also, a word of caution when making these connections: do not string the AC cabling so tight that it is placing a stress on the connection points. Once the AC connections have been made, you're ready to move on to step 5, installing the protective end cap onto the open AC connector on the last inverter in each branch circuit. Step 6, place the PV modules on the racking system and connect the DC leads from each of the PV panels to the microinverters, making sure that the connectors are securely snapped into place. The LED on the microinverter will flash green 3 times when DC power is first applied, indicating a successful connection. This startup indication only happens when the DC power is applied to the first side of the connected inverter. Check the DC connectors if you don't see the green startup LED flash. With the PV modules and inverters in place, and all connections thoroughly checked to make sure that they're secure, you're ready to energize the system. First, turn on the AC circuit breaker associated with each microinverter AC branch. Next, turn on the main utility grid disconnect. Note, as a safety precaution against potential islanding, the system will not start producing power for a full 5 minutes after it detects the presence of the grid. Now that the system is energized, a few words about the inverter LED indicator lights. The inverters have a number of LED indicators that are extremely useful in determining system status beyond system startup. Assuming all is good with the system once it has been energized, the LED will flash green slowly, every 10 seconds, meaning the inverter is producing power and communicating with the ECU as expected. If the LED is flashing green quickly, every 2 seconds, the inverter is producing power, but not communicating with the ECU. This is a normal condition if you have not installed an ECU as part of the system design. If, on the other hand, the ECU is part of the system design, and the inverter's LED is flashing green every 2 seconds, then you'll need to check the power line communication (PLC) path from the inverter to the ECU, as well as verify that the inverter UIDs have been correctly entered into the ECU. A flashing red LED is an indication that the inverter is not producing power. Check the DC leads to make sure that they are securely connected. A solid red LED indicates the inverter has detected a ground fault. For the most part, replacing the microinverters is as simple as reversing the installation process for removal and replicating it for reinstallation, with a few extra steps added to the procedure for your safety. You'll want to remove the inverter using the following steps. Step 1. De-energize the AC branch circuit by turning off the branch circuit breaker. With the branch circuit offline, cover the PV modules associated with the inverter to be removed with opaque covers, ensuring the panels are not producing DC power. Next, disconnect the AC connectors to the adjacent inverters. Step 4. Disconnect the DC connectors from the PV modules associated with the inverter. And finally, physically remove the inverter from the rack. Follow the installation procedures we've gone over earlier in this presentation to install the replacement inverter, making sure to change the inverter UIDs in the ECU and EMA to reflect the changes you've made. A few quick words about installing the ECU before finishing this training module. As mentioned earlier, the ECU collects and stores the performance data from each of the microinverters using the power line communication or PLC protocol, and sends it to the APS database via an internet connection so that the array can be monitored online. The ECU, while optional, is an essential component of the remote monitoring system that should be thought of as the gateway to the performance information that can be retrieved from each inverter and its assigned PV modules. It is also important to note that the ECU is not a wireless device and requires an electronic bridge or direct Cat5 connection to communicate to a network router. Before jumping into the actual installation of the ECU, it's extremely important to understand that it must be manually pre-programmed with the inverter UIDs prior to installation. Failing to perform this part of the overall installation process will result in the ECU not being able to recognize the system's inverters. We will be going over the detailed ECU programming instructions in another training presentation that is focused entirely on the ECU functionality. When installing the ECU, it's always best to establish PLC communication first, and then internet connectivity. The ECU is designed to be plugged into a 120-volt power outlet that is located as close electrically to the solar array subpanel as possible, preferably on a dedicated circuit to help enhance the PLC signal between the inverters and the ECU. Do not plug the ECU into a power strip surge protector or UPS backup power supply device because they distort and disrupt the PLC signal. With a stable PLC connection established between the inverters and the ECU, connect the ECU to the internet using one of the following three options. Option 1, which is the most straightforward approach, although not always convenient because of ECU placement, is to use a direct Cat5 Ethernet cable connection between the ECU and broadband network router. Option 2 is to use a Wi-Fi range extender to wirelessly connect the ECU to a wireless broadband network router. This option requires you to connect the range extender to the ECU using a Cat5 Ethernet cable, which in turn connects to a wireless router. Option 3 utilizes a power line adapter to make the ECU to router connection via the power lines in the structure. The typical power line adapter is a two-part piece of technology: send and receive units. The send unit is connected to the ECU, and the receive unit is connected to the broadband network router. This concludes the YC500 microinverter and ECU installation training. Should you have any questions, please feel free to contact APS Technical Support at support@apsamerica.com. The next presentation in the APS America Technical Training Series focuses on ECU programming and functionality. But before you leave, if you have not already done so, email APS Technical Support at support@apsamerica.com, letting them know that you need to get registered. Please provide the following information. Thank you for your interest in APS America microinverters and for attending this training session.